Next activity question we have, what is the value of P, a conditional A? Okay, knowing events A already occurred, the probability of A. Okay, this is a conditional probability, but it's very simple. So the question is asking, what's the probability of A occurring given A has already occurred? It's very simple. If something has already occurred, that means the probability of that event is 1 or complete. So probability is 1. Okay, next question. Given that events A1 and A2 are disjoint, which of the following is equal to P A1 union A2 given B has already occurred? So we are given that A1 and A2 are disjoints, which is equal to P probability of A union A2 given B has already occurred. This means let's use the formula first. Probability of A1 union A2 given probability B has occurred is probability of A1 given B has occurred plus probability of A2 given B has occurred. Why? Because these are disjoint events. For disjoint events, this is the formula. This is one variant of the main formula. Okay. It's simply A1 first, given B has occurred, then A2, given B has occurred, because this is a disjoint event. Moving to the next question, given 2p probability of A equals probability of B equals 5 over 13, probability of A given B equals 2 over 5. Evaluate probability of A union B. Answer the question correct up to 2 decimal points. Okay, we know 2pa, this is 2 over 5, and we know probability of A given B is 2 over 5. Let's first solve for probability of A. Probability of A is what? 5 over 13 times 1 over 2, because it's 2 here, right? So it becomes 5 over 26. Now, probability of B is straightforward, 5 over 13, okay? Now, probability of A union, A given B is 2 or 5, which simply means what? It simply means what? It simply means probability of A intersection B over probability of B is probability of A given B, right? This is the formula, right? So if we rearrange, we get the equation as 2 or 5. This goes up, this goes up, this goes to, this gets multiplied to this, and you get the intersection formula. So 2 over 5 over 5 over 13. This gives you 2 over 13. This is the probability of A intersection B. Now, probability, okay, you know what? Let me make some space here. I don't have any space. Okay. So, probability of A intersection B is 2 over 13. And we know probability of A union B formula is probability of A plus probability of B minus probability of A union B. We know the probability of A is 5 over 26. We know probability of B is 5 over 13. And we also know minus 2 over 13 is intersection formula. Okay, so your final answer is going to be 1126, which is 0.42. This is probability of A union B. It's very straightforward, just using some equations. That's it. Third question is, Dhoni is a player, played 2 balls in a cricket match. In each ball, he is equally likely to score any number of runs between 1 and 6. The runs scored in the 2 balls are independent. What is the probability that the product of the runs scored by Dhoni is a perfect square? Answer the question correct up to 2 decimal points. So let's solve the problem step by step. So Dhoni can score how many runs per ball? So Dhoni scores, he can either score 1, 2, 3, 4, 5, and 6 per ball. So per ball, these are the possibilities. For 2 balls, he can score total of how many runs? There are 36 maximum runs, outcomes that he can get. So in first ball, he can score 1, second 2, or second 1, and first 2, both 2, 1, 3. So this is 6, right? So there are 2 possibilities of scoring in 2 balls. So there are 6 total balls. So, oh, no, sorry. Not this. So there are 6 outcomes in the first ball, 6 in second. So total, how many he can score? 36. Okay. Now, product is a perfect square between 1 and 36. How many perfect squares there are? So the runs scored in two balls are independent. What is the probability that the product of runs scored by Tony is a perfect square? So between 1 and 36, there are 36 total possible outcomes. Okay, so perfect scores can be what? 1 is a perfect score. 4. So we are finding perfect scores. 1, 4, 9, 16, 25, and 36. These are your perfect scores. Now list all the ordered pairs AB with so AB are a perfect square. So these are your total runs in two balls, which yields you a perfect square. So what possibilities are there to get 1? It's 1 comma 1. 4. 4 can have, okay, so 1 can have only 1 or 1. First ball 1, second ball 1, and then that gives you 1. 4, you can have 1 4, 4 1, and 2 2. Okay. Likewise 9, you can have 1 9, 3 3, and 9 1. Likewise 16, you have 16 how many? 3 3 9 1. Okay. Do you know what? This cannot be true. 1 and 9 cannot be true because for each ball you're only getting 6 runs. You can't have 9 for a ball. So this is wrong, this is wrong. Only this is correct. 16. So you can have 1 16, 16 1. Okay. Then you can have 4 4, 2 8. But remember, 2 8 cannot be correct. 8 runs per ball is not possible. Likewise 16 is not possible. So here you're only getting 4. And then 25, same thing. You can't have more than 6 runs per ball. That's why it's 5 5. 36, same 6 6. So now if we sum up, how many are there? 1 2 3 4 5 6 7. There are 7, isn't it? 2. Okay, let me list down. 1 1. There's 2 2. Okay, and there's 3 3. Okay, 4 4. Okay, 5 5. Okay, and 6 6. Okay, so there are total 8. No, there is one more. 1 2 3 4 5 6. Okay, there's 4 1 and 1 4 as well for number 4. So now you have 8. So total 36. So your probability is going to be 0.22. That's your probability of getting